everyone, my name is Sethi. I hope you all are staying healthy. Today we are going to talk about sampling distribution, central limit theorem and standard error. First of all, we will see sampling distribution. Sampling distribution is just a way of looking a group of samples rather than one. Sampling distribution is just a way of looking a group of samples rather than one. For example, you have 10,000 students and you want to know their average height. Obviously, measuring everyone is very difficult. That's why you decided to collect samples. In sample 1, you randomly measure 30 students and their average height is 168 centimeter. In sample 2, you measure another 30 random students and their average height is 171 centimeter. In sample 3, you measure another 30 students again and their average height is 169.5 centimeter. You will repeat this process until you gather all possible unique combination of 30 students. This is sample mean, this is sample mean, this is also sample mean. Similar, now you have 1000 different sample mean. What will you do for this sample mean? You will plot all these sample mean on graph. When you will plot all these sample mean on graph, your sampling distribution is ready. That means by plotting all these mean on a graph, you will receive your sampling distribution. Continue with previous example. Average height of students, probability density. These are our sample mean which we earlier collected. When you plot all these sample mean on graph, you will receive sampling distribution. That means this will be called sampling distribution of sample mean of height. 170 will be called true population mean. That means the average height of student is close to 170 centimeter. This part and this part shows height which is very far away from 170 rarely happen. Now we will see central limit theorem. Sampling distribution is just a way of collecting so many sample mean. But central limit theorem give guarantee if your sample size is large enough. Large enough means if you have sample equal to 30 or more than 30. Central limit theorem give guarantee if your sample size is large enough, then your sampling distribution will follow normal distribution, or you can say that then your sampling distribution will follow perfectly bell-shaped curve even if your original population is not normally distributed. Your original population is not normally distributed, but your sample size is equal to or more than 30, then central limit theorem give guarantee your sampling distribution will always be perfect bell-shaped curve or normal distribution. Now we will see key properties of central limit theorem. Shape become normal. That means central limit theorem give guarantee if sample size is large enough, then sampling distribution must follow normal distribution even if original population is not normally distributed. As you increase sample size, spread of distribution become narrow. That means large sample give you more precise estimation. In central limit theorem, we calculate variance of sample and standard error. Variance of sample tell you how much your data point are spread out from sample mean. And standard error tell you how much sample mean deviate from true population mean. This is formula to calculate variance of sample, population variance, number of item you choose as a sample. This is formula to calculate standard error, population standard deviation, and this will be called square root of sample size. Mean remain consistent. That means according to this theorem, average of sample mean is same as a population mean. This represent mean of sampling distribution. This represent population mean. Both are equal to each other. If your population mean is 100, then average of all possible sample averages will also 100. Large enough requirement. This theorem only give guarantee of normal distribution if sample size is large. If sample size is not large, then this theorem will not provide any guarantee of normal distribution. Now we clearly understand what is standard error. When you collect samples from large population and calculate its mean, this mean can slightly different from true population. Standard error tell you how much your sample mean fluctuate or deviate from true population mean. Smaller standard error means your estimate are more precise and reliable, and this is possible when you have large sample. Formula to calculate standard error we have already discussed. Population standard deviation square root of sample size. Now we just see summary of today's video. Sampling distribution, collection of possible sample mean. Central limit theorem give guarantee if sample size is large enough, then sampling distribution always have a perfect bell-shaped curve or normal distribution. Standard error decide width of bell-shaped curve. Small standard error make bell-shaped curve narrow and tall, while large standard error make curve wide and flat, which obviously produce more uncertainty. This is all about today's video. I think you got it, and thank you so much for watching this video. Bye, take care.